Welcome, everybody. Tonight we're working on Module 7. The topic for the evening is advanced classes. Here's kind of a breakdown of our topics for the night. So we're going to basically build upon objects and classes. We're going to talk about inheritance. We're going to talk about overriding, the ToString method. We'll talk about what static means. We'll talk about this concept of aggregation. And then we'll talk about abstract as a feature and interfaces. And we're going to hit these one at a time. Some of these are kind of conceptually heavy, but very, very useful in modern programming. And once you get your head wrapped around these ideas propagate to most other languages, maybe not exactly in the same way, but in similar fashions. And weird acts of synchronicity in life, as they often happen. In my Python class over at Gateway, we were talking about many of these exact same topics just yesterday, right? That was like the lecture topic. And mind you, they're in a 14-week course and you guys are in an 8-week course. So even for them, it's right at the end of the semester that we're hitting these topics. What's really interesting, though, is C#, because it's what I call more of a traditional style language, has a little bit more granular control over these features, where what I find kind of uncomfortable both teaching and using in Python is it's so freeform, right? And that's not the case here in C#. C# is a pretty rigidly structured language, and that typically makes for better executing code, by the way. All right, let's talk about some of the concepts here that get us into this thought of inheritance with objects and classes. And it says here, in the real world, there's general things and specific things, right? So they talk about grasshoppers and bees, right? And the point really is that individual types of insects are unique unto themselves. They're very specific, right? But they do share some features. So like, all insects have 6 legs, 3 body segments, and an exoskeleton, right? I think a lot of, one thing that a lot of people don't know about insects is they all at one point will have wings also, right? Even ants at times have wings, but not always, right? That's not included here, but, and then all of them also have the things that make them unique, right? So they make this point that they have their own special properties. So for example, grasshoppers will jump and bees will sting, but grasshoppers don't sting and bees don't necessarily jump, at least not to my knowledge. There's kind of like a terminology you can kind of apply to this to help you kind of wrap your head around it. And we use this phrase, is a relationship, right? So for example, a grasshopper is an insect, okay, and whatever, is a insect. A rectangle is a shape, and a customer is a person. So on the left, we have the specifics, and on the right, we have the general, right? So a grasshopper is a specific type of insect, a rectangle is a specific type of shape, and a customer is a specific type of person. Okay, so that's going from the general to the specific. We're going to learn about superclasses and subclasses, and so the superclass basically applies to this concept of the general, right? When we're doing programming, we also call this the base class, right? Some people will also refer it as a parent class, and then we'll learn that there's a subclass, which we call the child class. So whatever terminology that you want to use is truly acceptable. Generally, with C style languages, and once again, that's like C, C++, C#, Java, and many others, we tend to use the language of superclass and subclass. So the general form, or the higher level, right, is called the superclass. And they're making the point here that the insect is really the superclass. It's kind of the general form of that little bug, right? And notice it says it contains things that are common to all insects. And for simplicity, they say here, like the name and the color is are things that are kind of generic. Then we have the specific, where, and notice they throw the word specialize in there. So when we look at the specific type of insect, we would call that a subclass. So notice how insect sits in the hierarchy above bee and grasshopper, because bee and grasshopper belong to the class of insect, and they inherit their essential properties from that superclass. But the bee and the grasshopper really become subclasses. The other terminology we use for subclass, as I mentioned before, is a child class, where the super is the parent, or the super can be called the base class, and the subclass can be called the derived class, because we're deriving from the base class the specific subclass. I know that's a lot of jargon there, and whatever resonates in your head the most. If you remember super and sub, that's probably most appropriate for most C-style languages in my mind. They make the point here once again, grasshopper and bee are subclasses. They contain things that are specific to that type of insect. And if you think of those two insects, you can think of their features and capabilities. Subclasses inherit from their superclass. And it says, because they are insects, grasshopper and bee both have a name and a color, because the superclass had name and color built into it. Right? So then we get into the specialization aspect of this. In subclasses, it says contain their own fields and methods to make them specialized, right? So for example, a grasshopper can jump. So it might have within it a jump method, and a bee, an insect, don't have that method necessarily. Like, can you imagine an ant jumping, for example? Yeah, probably not. But a bee has the sting method. It's an action or ability that the bee has that other insects may not. Some might, but most generally don't. So when we start to get to putting this into code, there's some terminology or syntax here that we have to learn. And generally, if we want to implement a superclass for a new class that we're creating, the subclass here would be grasshopper. And this colon insect indicates that we are inheriting from the insect class all of its capabilities and properties, basically its attributes. And those are now part of grasshopper. But grasshopper brings something new to the mix, which is its ability to jump, right? The same with bee. It inherits from the insect class, but it brings its own uniqueness in the form of being able to sting. And, this is the terminology we use here. Now, if we were doing this, for example, in Java, we literally say inherit or inherits, from a particular class. Here we use a colon. In Python, we throw the superclass into a set of parentheses. Same kind of concept, though, right? We're inheriting from the superclass. All right. Now, kind of interestingly, it says nothing special needs to be done to insect to make it a superclass, and the superclass in general isn't aware that there's a grasshopper or a bee. It doesn't really matter to the superclass. Insect is insect, and insect might only contain these things, right? Its name and its color. Sorry about that. Now, another thing that superclasses might have, and this is like one of these weird aspects of this, is there might be fields or attributes to insects that all insects share that really is not changeable, right? So for example, all insects have 6 legs. That's a given. And notice how that data field is set to private, right? And then of course we use the underscore in front of it to kind of symbolize that that's a private field. And that's not one that we're going to change, right? Well, if you change it and it's got 4 legs, well, maybe it's a mammal. Maybe it's not really truly an insect at that point. And interestingly, From Grasshopper, you cannot access this private because it's built into insect. So I can't go in there and change it at all. That's just kind of a given. Right. Here it says that with private fields and methods, right? So we can make methods private. So that, for example, we can make in the insect class the legs, that's a private, that's a data field. And then we can also make, the methods inside of it. For example, like to lose a leg, that's not something that would be accessible from Grasshopper. So what they're trying to say here is they exist in memory. They're not directly accessible though. So if you were in the B class, you can't call upon this method. You're not allowed because it's private. And then if you try to console write the number of legs, that won't work either because the B class won't have access to the privates in the superclass. I think that's really interesting. In Python, by the way, they do, which is really weird. All right. Now, we've already talked about what constructors are. And this is a really interesting feature of this super and subclass kind of approach. The constructors aren't inherited. So just because the insect class has a constructor, the subclass doesn't inherit that constructor. It needs its own, right? So, and the point that they're making here says, after all, their job is to create and initialize an object, and an insect constructor creates an insect object. Why would a grasshopper want to be only an insect? Because then it loses its ability to jump. You see, that's kind of the mindset there. So the fact that the superclass, might have a constructor, then in that case, the superclass will have its constructor operate first before the subclass. So in other words, when I create a grasshopper class object, it will grab all the features of the superclass automatically and then do whatever it needs to do to make itself unique relative to that superclass. So here's an example. If we have a general class called pet, right? And pet's got its own constructor, and all it does is say right line, constructing pet. And then we create a class dog, which inherits from pet. And then it has its own constructor that says constructing dog, right? And that's normally not what a constructor would do, but we're trying to make a point here. And so what happens is if I issue this statement and I say dog Fido is a new dog, the output would be, keep in mind, the constructors do a right line. The output would be that it would construct both. So both of those messages would pop up on the screen. So both constructors are triggered. This is a really bizarre feature. May or may not be what you want, right? Now, if the constructor, mind you, was populating some data fields, then, okay, well, that might be useful to dog. It doesn't necessarily have to put a message on the screen. But the point is that both constructors are triggered by virtue of doing this inheritance. Right. Now, interestingly, in C#, it says here that classes may only have one superclass. So in other words, they can't have two superclasses they're drawing from at the same time. They can only have one superclass, like one above it in the hierarchy, right? So a bee, even though I guess it's kind of an animal and kind of an insect, it can't have a superclass of both. They can only have a superclass of one superclass. However, you can do what we call multiple inheritance, in that insect can inherit from animal, and then bee can inherit from insect. Right? It's like you can't have two dads, right? One of them, is the one that created you, or two moms, right? One of them is the one that created you, and then your mom had a mom, and her mom had a mom, etc. Right? So that's how we inherit, right? So I don't know, what are the general features of an animal? Well, they're like living beings, right? And then an insect is a different type of living being that has 6 legs, an exoskeleton, and 3 body parts. And then bees and grasshoppers inherit from insect, but they're also animals, right? But they don't directly inherit from animal. They inherit from insect first, and then insect inherits from animal. Is how that works. All right. Another point here, it doesn't work in reverse. It's a one-way relationship, right? Like if you think of the parent-child example, that's a really good analogy for inheritance, right? You know, your parents aren't inheriting anything from you, but you certainly are inheriting from them, right? And anybody who has children, I'll often, it amazes me how powerful DNA is, and people can look at my 2 children and go, oh yeah, they're definitely yours, right? You can just tell immediately that they belong to you, right? But not the other way around necessarily. So it's a one-way relationship, and it says superclasses get nothing from their subclasses. They can't call their methods, and they can't use their data fields, right? But the other direction, it does work. All right, so it says here once again for the constructor, you can't choose to not call a superclass constructor. If you don't explicitly call one, C# will call the superclass's no arg constructor, right? And it says, what if the superclass doesn't have a no arg or default constructor? Or what if you want to call a constructor that has arguments? Well, all right, here's how we would do that. There's a special word that we use in doing the inheritance, where if the superclass requires certain aspects, we can call upon those aspects by using the base keyword, right? So here's the consideration. It says a person class that has a 2-arg constructor to initialize first and last name. So all persons have a first and last name, right? And then a customer, which is a type of person, has a 3-arg constructor that does first name, last name, and account number, right? That's what, so the account number makes the person or the customer different from a generic person. So how we would apply that, right? Imagine this scenario. Here's the person class, right? The super class, 2 data fields, first and last name, getters and setters, and then a 2-arg constructor where first and last are thrown in and then assigned to the data fields, right? That's our super class. All right. Now, I want to make a subclass of customer that inherits from person. And remember, the only thing that makes that person or a customer unique is their account number. And then notice in the constructor for customer, we want to accept 3 arguments, right? First and last, right? And first and last, mind you, come from person. And then we have the account number, but we don't have a first and a last here to deal with it. It is this connection up here that allows it to happen. So think about, why this is happening. It says a customer must call a person constructor, and the person doesn't have a no arg constructor. So C# can't call one like implicitly. So we can't like just, well, hey, let's just create it and we'll just be there. Nope, that's not how it's going to work. We have to actually tell the customer class when we're building it to use the base class to make it happen. So I think this will make a little more sense. So we can send 3 arguments to customer, but first and last, these 2 arguments here will go to the base class or the super class, if you will, where that can resolve those 2 things. So when a customer is created, it'll have all 3 pieces of information built in. It's just that the first and last name came from the person class. And the constructor here can handle them with the addition of this syntax, right? So very explicit into how you're making it happen. We're not implying that it's going to happen. We're forcing it to happen. We're naming it very specifically. All right. So why don't we do this? Let's build up some sample code here, and I'm going to launch Visual Studio. We'll try it out. So I'm going to create a new project here. I'm going to sit up in my seat, make a console app, and let's call this module 7. Try it out. I'm going to keep the top level statements in there at this point. We'll let it build out the app. And then I'm going to talk about kind of an approach we're going to use here tonight to do this stuff, because I don't want to create a bunch of separate class files. I'm going to put all the class definitions right here inside this program. And then in the main method up here, I'm just going to do function calls, and then I'll have functions that call the classes to do stuff. So here's going to kind of be my example. And this is an example, so I'll have like an example function, and I'll call it from here, right? And then down here, and maybe I'll do some comments here, list the functions, and I'll say like mini programs that deal with the classes below, right? And so in other words, I'm going to have a bunch of functions I'm going to write, and those functions will interact with the classes below. And then what I'm going to do here is outside the internal class, I'm going to create down here, a list of classes that the functions above will use. All right. And you'll see how this works as we kind of get rolling here. Right. But I'm just kind of labeling it so it's clear as to what we're doing. So the first thing we're asked to do is to create a rectangle class, or use your existing one. So if you want to go find it, hey, go for it. I think what I did with mine is I copied it in here somewhere. It should have length and width properties, and then we're going to add a toArg constructor that initializes length and width. So just for the sake of speed here, I'm going to help you guys out by dropping my code in the chat, so you can just borrow mine if you wish. All right, so here's my rectangle class, and I'm going to add that to my code file here. So here's my class, right? Length and width, and a toArg constructor. Okay, notice I labeled it a superclass. The next instruction is create a cube class that is a subclass of rectangle. It will have a height property, right? Length, width, and height, so it makes it three-dimensional. It'll have a 3arg constructor that initializes height, but we'll call the rectangle's constructor to initialize length and width. So here's how I'll do the cube class. And once again, I'm going to paste this into the chat for you guys, so you can just kind of drop it in and have it as an example. So outside this class here, I'll paste in the rectangle class. So this will become a subclass to rectangle, right? I know that because of this syntax right here, right? That one will add one new property for height, and then it'll take a 3arg constructor with length and width, and length and width will go to the base class, or rectangle, which is denoted by this little syntax here. So the constructor here will assign the height internally, and the length and width are part of the cube class, but they come from the parent class or superclass, and that's kind of the lay of the land there. Now, if you wish, right, and I'm trying to move all my silly windows around here. Many tabs and windows open here today. The way that I'm going to kind of deal with that, right? And they're not really telling us to do anything with this at this point, like, like go ahead and, create a cube, right? But I feel compelled to create a cube, right? Just to kind of prove that it works. And so what I'm going to do is here where I have my functions, right? So notice where this is located outside the main method, but inside these set of curly brackets, right? So right below this line, I'm going to create a function, right? And it's not going to return anything. So I'm going to make it static void, and I'm going to call it cube. And then a set of curly brackets. And then what I'm going to do here is I'm going to create a cube. So here's my code to create a cube. Length, width, and height. Right. Oh, semicolon. Yeah. Right. So that would instantiate one cube. And remember, cube, this class type, inherits from rectangle. And then to prove that it works, I can just very simply console write line all three of its features, right? And once again, if you guys want to save the typing, and I know some of you have already typed it in too late, right? Here's the code. You can just borrow mine as an example. And then up here in the main method, what we're going to do, and I'm going to put a little comment here. The main method drives all the functions, right? So all I have to do now to make this work is call cube. So I'm just going to call the cube function like that, and it'll run this code, which will draw from the classes below, and then we should see it up on the screen. So I'm going to go ahead and run this, and then all we're going to see is these numbers put back up on the screen, but it'll show you that it actually worked, and there you go, right? And so we were able to create a new cube, 2.5 the length, and the width of 4.76 go to the parent or the superclass. 11 is generated in the subclass, but altogether they make a cube, and those data fields travel with it. So I can create the cube and extract its length, width, and height, even though length and width really come from the superclass. So that's kind of the example. So cube is inheriting two of its properties from the superclass. All right, so that's kind of our example on this one. All right, let's keep moving forward here, folks. Let's start talking about this concept of overriding. All right, and I want to be really clear here because we're going to talk about overriding and overloading, which are two different things, right? And they're commonly confused, by the way. So the first topic is to override methods, right? So it says a subclass can have a method with the same signature as a superclass method. When they do, the subclass method will override the superclass or the parent. So for example, it says pet has a class called speak that writes hello, and dog class inherits from pet and overrides speak to write woof. All right, so that's kind of a weird thought, but here's kind of the example. So pet's the superclass, and notice that it has its method here called speak, and its speak method is generic for all pets. So like, if a pet doesn't have a sound it makes, well, it's going to say hello, right, in the program. The keyword virtual, which you'll start seeing being added in here, indicates that it can be overridden. So unlike some other languages where, you can just override if the signatures are the same, with C#, you got to tell it with this keyword virtual that you're going to allow an override from the subclass if we so choose. So this is like the control aspect of C# that other languages don't necessarily have, non-C style languages. And I'm thinking, specifically Python, because a lot of us learn that one these days. All right, so in overriding this, notice what happens in the dog class. So dog inherits from pet. It has its own speak method with the same signature. And what we mean by the signature, by the way, is the method name with whatever parameters it accepts. That combo is called the signature. So these both happen to take no data or parameters in there. But notice that there's the use of the keyword override in there, which means this will override the method from the parent class or superclass with the same name, because this one's set to allow for it. It doesn't happen accidentally. It's done explicitly. This is what they mean by that, right? And so if I run this code, notice it says C# always chooses the lowest implementation, meaning the subclass method will run if both share the same thing and the code's written correctly, right? And the superclass method will not run. So if we create a new dog and I tell Fido to speak, it runs the one from dog, not the one from pet, given the code that we've just looked at. Now there is a difference, right? And this is the thing I mentioned before, because these two words get thrown around a lot in programming and people don't always latch onto their true meaning. Overriding, right? Or let's talk about overloading. Overloading is when two methods have the same name and different parameter lists. Now we saw that with constructors, right? Like you have constructors with no arguments and constructors with arguments, right? And then that combo of the name of the method with the data going into it creates the signature. And so, for example, overloading happens within the same class. So like if I have two add methods and one takes a list of integers and the other one takes an array of integers, those are different signatures. And whatever data you're sending in determines which one will run. That's overloading, right? Right. Overriding is when you have two methods and there's an inheritance going on, and those have the same signature. And provided you've set up your keywords correctly, so the superclass has virtual and the subclass has override, the subclass override will happen before the superclass one will happen. And once again, like if we were doing this in Python, we don't have these keywords to work with, but you do have these keywords in C style languages because they indicate a very specific level of control. All right, I think we're at a good stopping point right now. So let's take a 5-minute break. We'll pause the video and then we'll come back and talk about the ToString method. All right, back from break and moving on to the next topic here, which is talking about the ToString method. Before we dig into the method itself, we're going to talk a little bit about how object-oriented languages like this function. There is kind of like the superclass of superclasses for all objects inside of this language, and it's called the object class, by the way. So every like tree of inheritance, if you could follow it all the way up to its ultimate beginning, there's somewhere in the C# language libraries this object called object, right? Or system.object. And it says if we don't specify a superclass, object is the superclass, right? And so ultimately that's the parent class for all objects. It's kind of like the container for all of them. And it says if a superclass contains what subclasses have in common, what can all classes in the C# language possibly have in common? All right, so that's kind of an interesting question if you think about it. And so ultimately it says every object can generate a string representation of itself. And that's because the parent object class has this method built into it called ToString that's spelled exactly the way we see it on the screen here, with a capital T and a capital S and an empty set of parentheses. And what this allows us basically to do right? So on any object that we create of any sort, right, since it draws from the parent object, it has that built in. And that allows us, for example, if I create like here a new customer and I go to write line customer, the reason it can write line it at all is because it has a ToString method that comes from the object superclass. And if I run this code here, this would be the output. Not very meaningful, but it does, tell you where it's coming from. So module 7, by the way, is probably the namespace of whoever created this PowerPoint, and then customer is the class within it, right? And so in other words, if whether you write line it like this or write line it like that, that's the information it natively pulls back. It doesn't tell you the data properties. It just tells you what its object structure, excuse me, is. Okay, maybe that's kind of useful from a namespace perspective, like where it kind of is coming from, but it's not useful in terms of telling you what data sits inside of it. You can actually call the method explicitly, so you can append, like if you're right lining an object, you can actually add the ToString method to the end of it, and it still gives you the same output. So you got your choice. You don't have to call it. If you try to right line it, it goes to the ToString method to try to output it. If you explicitly call it, does the same thing, right? It says here the default behavior of ToString, not very useful, right? I agree, right? The only thing it's really kind of useful for is kind of identifying the structure of where your object is coming from, and that's kind of about it. However, we can write our own ToString method that overrides the original. And if we do that, it will use our version rather than the one that comes from the ultimate superclass of object. We are going to add the keyword virtual. So for example, in our, subclass, we're going to throw in public virtual string ToString, right? Because it's returning a string, it's virtual, right? So this exists in the master or super object class, has this inside of it, which is why we can override it in the first place. When we write it locally in our own class, we throw an override, we call it the same thing, and it will override the one in the super class. Then we have the control, right? We can put inside that ToString what we want to put inside of it. In other words, I think it would be useful, and I think this is a good example where we want to see certain pieces of information to verify that they're in the object, right? So like if I have a customer class and I create a customer object and I give it values for first, last name, and account number, I can write a ToString method that puts it up on the screen. That is truly more useful. But notice it says the signature must match exactly, right? So I can't make this like a lowercase s or a lowercase t. Oops, I didn't want to do that. And it has to return a string, and it can't accept any parameters. So when we say the signature, it's the name, it's got to include the override, it's got to return the same kind of information, and it has to accept the same number of parameters, right? So override string ToString, that's got to be in there, right? And then we can utilize that in a lot of different ways. It becomes very, very useful. The other point that they make here is we can do this with what we call the object initializer, which is this little, I call this a lambda expression typically, where it's an equal and then a greater than symbol. And basically what it's doing is it converts to a string, whatever we want to call it. So it's going to return this. So really what this is saying is ToString returns this string. And notice, the use of the $sign here for string interpolation, right? So a lot of programmers really like this approach. Either approach, right? If you do it like this, that's fine. If you do it like this, that's fine. They're both functionally the same thing. This is maybe a little bit more efficient, I would say. So now if we use our own ToString method and I console write line the customer object, look at the output, much more useful, right? Because it shows us what's inside that object and what data that object has. So very, very practical for sure. All right, we got a little try it out here. So let's do this. And once again, I'm going to try to share code with you to kind of make it go a little bit more efficiently. And so it says create a class named television with the following properties: a Boolean for whether it's on or off, a double for the current channel, and a string for the manufacturer. So let's do that. I'm going to find that code here in my example file. So over here in Visual Studio, down here where I have my list of classes, and the way I'm going to do this, by the way, is newest on top. So when I add something new, I'm going to put it at the top of the list, not at the bottom, just to try to minimize scrolling a little bit. And so I'm going to create a public class television. Right, some curlies. I'm going to throw in my data fields. So I got a Boolean called is on. Notice how that's in the form of a question. So is on is true, the TV is on, right? Is on is false, is the TV is off. And then the current channel that we were told to make that a double, and then the manufacturer. And, you know, kind of, I don't know if you guys are noticing, but I just put a get on there and not a set, right? And so kind of the thinking is removing the set means that you can only set it in the constructor, right? Because think about it. If you build a television set and it's made by, I don't know, Samsung, you're not changing brands after it's built, right? The brand is set when it comes out of the factory. That's not a changeable thing. But I can turn it on and off, and I can change the channel. So the thinking there? All right, so that's kind of my little hack on it. All right. So next task. Create a ToString method that returns a string like the Sony television is tuned to channel 4.1. It is currently on. In a driver class, create and write some television objects to test your ToString method. Okay, so here's what I did for my ToString method. And if you guys are waiting for me to paste the code, I will do exactly that in just a moment here. In fact, here it comes. Right. Patience is a virtue. So I created a override method, turns a string named ToString exactly as it is in the superclass object. It returns directly this little statement here. So the whatever manufacturer is tuned the channel, whatever, and then I ask them the question, is it on or off? Right. Well, we kind of have a little bit of a problem because we haven't turned on the TV. So whatever TV we're going to check, what is its default value going to be? That's kind of an interesting thought. So here, you might want to add a constructor in the mix here. Right. So I'm going to throw in a constructor. Here's the constructor. And notice that when I create a television object, I can send in the current channel and I can send in the manufacturer. By default, is on will be set to false, right? And then the current channel is the current channel and the manufacturer is the manufacturer. And then if you want, I could write another method called turn it on, and then I could trigger it and then check it. And if you guys want to go to that trouble of writing that code, hey, go for it. Just fun little code to write. So that's my whole television class there. Once again, I put this way at the bottom of my code file, so I don't have to write separate files for this. I'm going to move up now. Then up here where I'm doing my functions, I'm going to create a new function above my cube function. And what am I going to call this one? What did I call it last time? I called it television. How clever. All right. So, all right. So the way I wrote this one is I did static void television, parens, and then curly brackets. And then we need to instantiate a television, right? So I would create a television object, right? And let's just kind of play with this a little bit here. I'm going to just right line it and see if my ToString method's even working, right? So I set the channel to channel 4.1. I made the brand Sony, just like the example. Up here in the main method, right, I'm going to call television. And then I'm going to comment out cube. I don't want that. I don't care about that one right now, right? I just want to run television. So as we kind of move along here, I'll write functions that access the classes, and the main method will trigger the functions. See the logic there? So one little command in the main method runs the whole thing. All right, here's the run. And if it worked correctly, I should see the output of my ToString method, right, which is the Sony television is tuned to channel 4.1. It is off. I don't know how you would know it's on channel 4.1 if it's whatever. You know, I'm not worried about that logic right now. All right, but here's what we could do. All right, and by the way, here's this code in the chat if you want to borrow it. It's a little bit more fun if we turn the TV on, right? So notice TV dot is on is now set to true. And then the current channel, I'm changing it to channel 5.1. And then I'm going to right line it again. So let's run that. And then you'll notice that now it is on and we're tuned to a different channel. Right. If you want to play with it a little bit, you can generate as many televisions as you want. And so, for example, what I did is this. I created another television. And by the way, I'll give you all the rest of this code, so don't freak out if you want to try it. All right, so I created television 2, and I put it on channel 1001.5, if there is such a thing. That one's a Samsung. And notice this time I explicitly called the ToString method. Then I'm going to turn it on, change the channel, and call the method again. So let's run it and see what happens. Did it work? Yeah, there it is. Right. And I'm just moving this off to the side so you can kind of see the result there. All right, so this is an example of creating your own ToString method that overrides the object superclass ToString. And I find that that's a really useful thing to do, especially if you anticipate using it. And Caleb, I do see your hand up there. What's your question, sir?
Yeah, I just was wondering, I didn't see with the override command, I didn't see the virtual. Did you have to put virtual in?
Yeah,
The
okay, so just to clarify that, that virtual, this part is in this file, the object CS file, which we don't see. It's
Oh,
part of the
okay, gotcha.
system class, which holds the
Okay.
object class, and all objects we create draw from that class. Its native ToString method allows for overrides by virtue of the fact that virtual is there. If I'm building the superclass and I want to override its internal method, I have to use the virtual keyword, but that's in the superclass of object. But good question, right? And now I think you totally see it a lot more clearly rather than my droning presentation of it. All right, let's talk about this word static. All right, because I've been kind of using it. I don't know if you guys noticed that and what it means. And when we start dealing with objects, right, we have the class definition, and then we instantiate an object based upon the blueprint of the class, right? We call that an instance, right? So when I made a television, I made a TV, and then I made a TV2. Those are instances of the television class, right? And the data properties within it are then called instance fields or instance properties or attributes. A lot of different names people will call them, right? And it says every instance of a class, each separate object that you create basically gets its own copy of, in this case, with rectangle, their own length and width. Every rectangle, they might have the same length and width, but they're their own copy of it. So they have an example here where the length is 5 and the width is 10, and the other one, the length is 7 and the width is 3, right? So they carry their own data. There's also the methods that travel with the object. So if you have methods within the object, those belong to the instance. So like when I create a rectangle and it has a method inside of it called get area, which multiplies those two things together and returns the value, those are unique to that object, right? And it returns the area of whatever object you're dealing with. So if there's a different length and width, you're going to get a different number each time, right? And so then we have this concept of the static, right? And static members. And it says static members belong to the class itself, not to the instances, right? And we'll see what this means as we look at some code. And sometimes we have fields that are static, and sometimes we have methods that are static. And so all instances share the same copy of those, meaning that they don't get their own individual ones, where length and width, they get their own individual ones. And if they have a get area, that's their own individual get area. And what's interesting about this too, and it says you don't need an instance of the class to access static members, right? Okay, so whenever we declare fields with the static keyword, they belong to the class. And it says only ever one copy in memory, regardless of the number of objects. Okay, so if I create a private, for example, and I say private static int, so it's an integer, and I called it underscore count, and I set it to 0, all the objects that are created from that class will have that set in there as a count of 0. They're initialized once. And when does that happen? The first time they're referenced, and then it appears in memory, and then that cannot be changed. Remember, the word static means not changing, right? They give examples of static methods. So this refers to static fields, like data inside the object. But we also have static methods, and the example they give, and we've kind of been using some of this stuff, right? Like if you use like math functions, we can call, a math class object, right? And we can use the min function where we send in 2 values and it figures out which one's smallest. And this is a static method where we're not changing anything inside of it, but that method can run. Right line is actually another example of that, which is really pretty weird, right? So that one's also a static method. All right, so they're giving this example here, and this is the one I think, I'm not sure if I'm going to code this one or not. I may or may not. And I'm just looking here. Did I do this last time? Yeah, I did. So I guess I'll code it. But it says, let's make an employee class, fields for name, and salary both passed into the constructor, a field for employee ID not passed into the constructor, and each employee that is hired gets a successively higher ID number, right? So in other words, you hire one person, their ID number is 1. Next person, their ID number is 2. Following person, their ID number is 3. And that is a field that's going to be built in, but it's static in terms of the fact that it belongs to the object or the class it's coming from, and not to the object that ultimately holds the value. However, and you'll see this, and this is kind of clever, it can still make it unique. So let's go ahead and build the class structure first. And so what I'm going to do is come down to the bottom here where I have my classes, and above television, I'm going to build this. So I'm just going to say public class employee. And yes, I will share if you guys want to hold off on the typing. I'm going to build the data fields. And I'm going to do this one step at a time here, right? So I'm going to put in an employee ID. Want you to notice once again, no set here because this is going to be preset in a different method. We can only return that value, the name and their salary, right? And then I'm also going to add a private static int here, and I'm going to call it next employee ID. And I'm going to set that to 1 because this is kind of weird. What's the value of an int if I don't set it? 0, right? And what's the value of a string if I don't set it? Empty quotes or null, basically. But this field here, we will be adjusting this as we go, but it's not going to be adjustable from the outside. It's going to be only adjustable from inside this class object. So here's how we will do this, and this will be kind of interesting. And I'm going to just drop in all this code at once. I'm kind of like jumping the shark here a little bit on all the examples here. But I'm going to put in a constructor that'll take the name and salary, and those will get applied here, name and salary. And then the employee ID will take the value of next employee ID, which starts at 1, and then we'll increment it by 1. So that will become 2 in the class, like the master object, so to speak. And then every time I add a new employee, it'll increment, but the employee ID will be unique to the object. This will be part of the object. This will be part of, the object that will never change. We can't access it. It only accesses once, right? I will put in a get next employee ID so we can look at it if we wish, right? And then I have a ToString method here. I use the little pointer thing instead, right? So that we can look at it. So this is the whole thing here. I am going to drop it all in the chat. So just hang tight. Don't type. Give your fingers a rest. All right, there's the whole thing. All right. So with this one, I'm going to come up top here. I'm going to comment out television. And then we're demonstrating this concept of static at this point. So I'm going to call this one static demo, right? And you notice I haven't written this function yet. And did I show you guys the trick, right? Where it's like I'm calling a function, it doesn't exist. And I can say, use this command here to generate the method static demo. And there you go, right there. Except not where I want to put it. I'm going to put it here. Like that. And I'm not really too worried about it being private, so I'm going to strike that. I'm just going to say static void static demo, and then I'm going to blow away this code here. So you guys should create that on your own. The next thing that I'm going to do, and I'm going to share this in the chat, right, just so you guys have the example, is I'm dropping in, oops, that's not good. Let's Control Z that. I'm just going to drop in all the inner code. And if you guys notice what I'm doing here is I'm generating 4 employee people, I guess. And notice the clever names there, right? Borrowed from our video game existence, right? And I'm assuming the number there is an hourly rate, right? So the name and their salary amount, and then the right line, of course, will print out the ToString object, and then we'll take a look at what's the next employee ID, and then we'll create 4 of these employees. So let's give that a shot and see what happens. Right? So there is Mario, right? See a salary. The next ID is 2. And then, notice we're printing the ID number here, right? So Luigi is employee number 2. the next thing gets incremented, etc. Right? So we are taking that one static field that can't belong to the object, belongs to the class, but we're able to change it and then increment it and pump it into the next object in the form of the employee ID, which then sticks with the object, you know. So this travels with the object, right? And then this is stored inside the class in memory. So then when the next object is built, we increment it and add it. Kind of a clever approach. And I think, like I said, I think I kind of jumped the shark here on the slides, but just kind of to step through them, you know, to make sure we cover the material, right? So we add that static int like we did. We assigned a value to it. So we started with the number 1, and then every time we would take the next employee ID and put it into the employee ID, we would also add a plus plus to the end of it, right? And you can do that right here, and that's how we did it in the code, right? So in our code, in the class, I just put that right there. Because when you do the plus plus after, it uses the value in it, and then when the statement's done, it increments, not before. That's why when we ran this code here to get the next employee ID, it shows the next number, because once, you know, we've done this, this has been incremented, or the next ID has been incremented already. Right. So that's what we did there. Right. So we did this. We created a getter that returns a static field. And then should the method be static or an instance method? And what did we do? We made it static here, right? We're not changing it. This is not something we want to change. We're just using the information. So static is appropriate. Right. Remember, static means we're not changing it. Right. Then we created a driver. Okay. We didn't do a loop that creates a bunch. We just wrote them out. Doesn't really matter too much. And all right, so limitations of static methods. It says static methods cannot access instance fields or instance methods. And so, for example, right here, if I want to return this directly, right, that's not going to work, right? You know, and the reason is because of that static designation. All right. They want us to play with the rectangle class here, and I'm not sure if I have this one queued up here. So I'm just looking at my code file. Please bear with me here. My sample code file is quite long for this unit, by the way. Many, many lines of code, hundreds actually of lines of code. All right, so it says, using the rectangle class, create a static int named _count that starts at 0. Create a method named getCount that returns the value of count. And then in the rectangle constructor, increment count. In the main method, create a few rectangle objects and use the getCount method to print how many have been created. All right, so this is how I handled this little exercise, by the way, the last time I did it. In the class declarations down below here, so we're going to put the newest on top one more time. I could use the rectangle class I already have, but here's what I did. I ended up just creating a new class called rectangle2, by the way, right? And yes, in the chat. So we still have our length and our width, right? Then I created a private static int, just as I was told, _count set to 0. Our constructor kind of does the same thing we did with employee, right? Set the length and the width, those are coming in. And then the count is just incremented, right? It's at 0. We'll use that and then we'll increment to the next count. Um, I also have a constructor that's no arg. So if I don't send in a length and a width, it'll just assume it's one, right? Length and width are one, and then it'll still increment the count. And then I also created uh, a method called get count that just simply returns it, right? Up above, I'm trying to find my code here. I'm going to create a new function, and let's call this, last time I called it rectangle demo. And you can use the right click if you wish to generate that, but I'm going to drop in my code because I already have it created. This is what I have, and you will notice there's some stuff that's commented out here. So I'm going to drop that in right here. So we'll make one rectangle, we'll get the count, make another rectangle, get the count. And if you want, you can write loops to do it, make a whole bunch of them. That's up to you, right? And if you want, what I suggest that we do is we do another rectangle, and you should type this one in manually, rectangle 2 actually, and we'll call it R3. And this time we'll do new rectangle 2, but no arguments in the constructor. And then we'll console right line it like that. I know I'm moving kind of quick, folks, but we do have a lot of material to get through. So I know that can kind of make your head spin a little bit. All right, I'm going to go ahead and run this one. All right. And what is it giving us back up on the screen? Just the count of the rectangle, right? And notice I didn't do like a ToString method. Really, all we're doing is getting the count, right? First rectangle is 1, second rectangle is 2, third rectangle is 3. Kind of hammers home that whole static field thing. And really kind of a clever way to do incrementing data for objects automatically. It is a pretty common thing, you know, especially when you're dealing with like database like information. Sometimes you have fields that you want to increment automatically like that. All right, let's move on. Now we're going to talk about aggregation, right? And, you know, we do refer to this in different ways in different languages, by the way. In C#, this is kind of like the primary way we refer to it. And the word in and of itself means a whole made of parts. And so what, and, you know, interestingly, I was teaching this in my Python class last night too. And let me do the explanation here first, and I'll show you the correlation. And what we say here is that a whole made of parts, when one object contains another object. So in other words, I have a class definition that includes a class definition, right? So a class defined inside of a class. So when I create an object, there's an object inside of an object. And the whole point of it, right? And in Python, if you're curious, what do we call this in Python? We call these inner classes. So like think of a class structure, and then inside of it, I have more classes. And what it really ultimately brings to the table is a simplified syntax for referring to the contents of objects. You know, very clear dot syntax is really what we think about. So, and it says here, it mimics real life. So for example, a house, which could be an object, contains doors and windows, each of which are objects, right? And it totally makes sense from an English language standpoint. And think about it. A house has its own properties and capabilities, right, and methods. And then a door has its own data and capabilities and methods. And a window has the same thing, and they can all be considered objects. So doors being an object inside of a house makes sense. And windows being an object inside of a house also makes sense, right? Or, for example, a course that contains an instructor, an object, I guess, a textbook and students, each of which are objects. And notice students are plural, so it's kind of like a list of objects. That's entirely feasible. And it does lend to this terminology, right? So earlier we were talking about like a dog or, a pet, or a dog is a pet, that kind of thing. In this relationship, we call it a has a relationship. So a house has a door, a house has a window, a course has an instructor, a course has a textbook. So you see kind of how that fits together syntactically. The example they want us to try here is to create a company class that contains 2 employees. So now we're going to start to use this class inside of a class concept. And we're going to like basically create a president and a vice president. And I guess there's no regular employees, right? Company of 2, you be the president, I'll be the vice president, right? And the company should also have a string for the company name and an int for the year founded. So once again, I'm searching through my code here on the other screen, and I'm going to give you all this code in one fell swoop, folks, right? This is what we call efficiency, right? So there it is in the chat. I'm going to drop down to the bottom here, and I'm going to add my newest class to the top, which I call company. And then I'm just going to kind of review its contents here. Right. So here's where we're kind of doing something interesting, because we are creating a class called company. And I want you to notice here, I'm not like inheriting anything, right? But what I'm doing in my data fields is I have a string and I have an int. And then you notice that 2 of my data fields are employee objects. So those objects get built in to the class of company. So when I create a company object, that automatically includes a president object and a vice president object that exist inside of them, right? And you can think of those as inner classes in a sense, or inner objects really is what they are. And we'll call that aggregation. And then I have a constructor there that takes the name, the year you're founded, the president's name, the president's salary, the VP name, and the VP salary, and assigns all those values. And then notice on lines 107 and 108, right, when I take those values, instead of just, directly applying them to a data field in a different object, I'm constructing a new employee object and storing it in this name called president, which is attached to the object company that we create, which will have its own unique name. So every instance of company will have its own president and its own vice president, all of them unique. So really kind of an interesting thought here. We have a class object that we've already created called employee that has its own data, that has its own methods. And then functionally what that becomes here is our own custom data type. That's really what we're building here. We're building our own data type, right? And conceptually, this is pretty deep, folks, right? And if, to kind of give you an example of that, we've already kind of been doing this all along. We've talked about the fact that strings really aren't strings. They're technically a class structure, which is an array of characters. It's a complicated data structure, and strings have their own methods, right? I can check the length and I can go 2 upper or 2 lower, or, that kind of thing. And so that's actually an example of the same type of thing. So strings are really objects, right? And then when I have my own object, I'm dropping in as a piece of data or a data field inside this object. It's a custom data type. Kind of an interesting thought. All right, let's go ahead and instantiate some of this now. So I'm going to come up top here, and we're going to create another function. And this one I'm going to call company demo. And then I'm going to find my code here. So just hang tight here. Somewhere in this chaos, I have an example. Once again in the chat. And you'll notice, I created one company called company. Um, okay, so you can tell I did this around Christmas time last year, right? So we're going into the holidays. So we'll call it Toy Factory, founded in 1800. Santa Claus is the president and Mrs. Claus is the vice president, but they both make the same salary. And we can do that. Now, if you want, you could add more companies. You can create company 2 or company 3 or whatever. And so let's just run it so you can see that it actually works, right? And so we have Santa Claus, ID number 1 with the salary listed there in numeric format. Now, remember, where does this stuff come from? From the employee object. Remember when we saw Mario and Luigi with that data, right? That same structure, the employee number. Did you notice that in this class, I didn't specify any of that because that's all contained in the employee class down here. Their ID number, their salary, their name, all that stuff is generated here. So when I use it up here as a custom data type, all the capabilities, even the ToString method, gets built in to this object. So it's kind of aggregating 2 different employee objects inside here, each with their own uniqueness, a president and a vice president. And then that whole object becomes part of whatever object we create with the company class. And it all travels together in layers. It's all aggregated. And, I'm hoping you guys are latching onto this conceptually because this is pretty deep and powerful. And the other beautiful thing about it, right, and this might not be quite as apparent, at least in the way that we're using it right now, is the simplistic syntax that we have in getting to the pieces of information. Because I'm just dropping company president into a write line. How does it give me that output that I see here to the screen? Because the employee object, which is part of the company object, has a ToString method that can put this on the screen. And it just simplifies the syntax. And if you get really good at aggregating together your objects, you can create dot syntax in code where it's like company.president.salary. That kind of thing. And if you name things well, the code is very readable. And I think this is really, yes, please, Bob.
Question. If you go down to where you define your company class, and I'm looking at the where you declare the employee president and vice president. That's the same format as a property, and you have getter and get and set.
Yes.
How would you use that property?
Well, partially in the way that we just did. In this case, okay, like a get and the set. I think I see your larger point, right? Because like if we're setting these values once, do we really need to set them again? So do I need a set here? Is that what you're getting to?
Well, I mean, where would I say it? Where in the code would I ever say employee.vice president equals? Did you do that somewhere? No, you did it in the constructor.
No, I see your point, right? So get and set really allow you to dig in and change those properties, but what you're getting and setting would be determined with these data fields here. So for example, if I wanted to say president dot name equals Joe. I could do that because it has the get, or excuse me, the set on it. So I could dig in. It now would stem off the company. So if I create a company object, I would say company dot president dot name equals, you know, Rudolph, you know, something like that. But that's actually a really good question, Bob, because it allows you to kind of drill down that way. And it's because the one object exists inside the other.
But you would never do company.president equals and then something. Because it's got multiple.
Yeah, I see your grand point, right? Like I would never do company.president equals, right? Because president has multiple data fields. So I have to identify which data field I'm talking about.
Okay, thanks.
Yeah, and I think, you know, if you wanted to kind of prove the point on it, you could do something like, and I'm not sure if this will work, but I'm pretty sure it'll work. If you say company dot president dot, and notice how it pulls the data fields in from there.
Mm-hmm.
Name. And then I can, okay, it wants me to read line it, but I can just set it to Rudolph the red-nosed reindeer, if I can spell it. Okay. And then we could console right line that again. Let's run it and see if it works. See if we were able to get and set that. There you go. So we fired Santa and the reindeer has now taken his place. But once again, you know, the syntax here is kind of part of the benefit of this, right? Mm-hmm. So this is an object inside of that object aggregated together, and we can still access the inner object's properties and change them. So I think powerful for sure. Now, we didn't really work with methods, but we could also trigger methods inside the inner object as well, using that same syntax. Here's the part that goes even deeper, Bob. You know, if you want to conceptualize this, we went 2 layers deep. It's conceivable to go 3, 4, 5. If you can conceive it, you can totally do that. Mm-hmm. Right. When we think of a data type that's more simplistic, like a string, right? We think of a string as being simplistic, but really it's a complicated data type. These objects that we created are also complicated data types with multiple data points and multiple methods that travel with them. And we're a lot more comfortable embedding those into inner objects than we are, you know, objects themselves, you know. But once you get the concept that functionally they're equivalent, it kind of like opens this magic door in programming, I think, for a lot of people. Object-oriented is a really, you know, it's a catchphrase we've been throwing around for decades now. And I don't think a lot of people really conceptualize truly when they're learning this, you know, because what happens is you got an 8-week course. We spend 2 weeks on objects and classes, and we're hitting upon some like pretty deep waters here, folks, you know. But the door that this opens is huge. Like once you get these concepts rolling forward in programming, it's super empowering. And then you start to see the reason for creating this kind of stuff and the syntax that it brings. I mean, how beautiful is that, right? Right, really. And you know, if we were smart, we'd call the company Santa's Workshop, you know, and then it would be Santa's Workshop.president.name, you know, and a lot more meaningful. And you know what? We put in very simple data points on all the objects. Could you imagine, you know, like if, you know, the company, really, you know, there's a lot more information that goes to the company aside from a name and a year founded that you could embed into the object. You could have 20 data points in there.
Mm-hmm.
And some of those data points could be other objects that have their own data points that go really, really deep. Right. And then ultimately it leads to a very clean syntax on the top level where you're coding. And that's kind of one of the parts of, today's class really is like, here I have this main method where in the past we'd write all this code. And now I'm just like writing one line of code that triggers a function that triggers a couple of classes and does all this work with one line of code. That's some powerful stuff there. And this is really kind of teaching you what object oriented is all about. So you write on the top level of the program like you're sitting in the car pressing, heated seat. I don't care how that works and how it got there, but it makes my butt warm and it feels good in the winter with one single button press. And then that's kind of what we're doing here. Folks, I think we should take another break, right? We hit upon some pretty heavy concepts here. And I think we're going into another section. So let's come back and we'll talk about abstracts and interfaces. But first, a 5-minute break. So I'll see you guys in 5. Let's say about 8:52, 8:53. All right, back from break. And now we're looking at our next topic area here called abstract and interfaces. All right, so some really important concepts once again here, and hoping to do a little bit of explaining, what these concepts are, because these are very important concepts. And, just to understand the word abstract, and we use this word a lot in programming where we talk about abstraction, right? And so like we use kind of like one word really to kind of represent the whole concept or collection of concepts often. And then we compare that to the word concrete, right? And here's an example, right? So it's they're saying you can't walk into a pet shop and buy a pet, right? So, hi, I'd like to buy a pet. Can you be specific is what they're going to say. Like, what kind of pet do you want, right? But you can buy a dog or a cat or a fish or a bird or, a lizard or whatever. But generic pets aren't really a thing. It's an abstract idea. It's a concept, right? Like all of those specific types of animals fall into that concept, but it's not really a thing. It's not something I can tangibly touch. Where a dog or a cat I can. And right now I'm reaching down and petting my dog that's laying right by my feet here, like she always does when I'm doing these classes. And it says, if we don't have generic pets in the real world, maybe we shouldn't really have them in our program, right? So I shouldn't really have the ability to instantiate a pet object that really can't really be, right? Because we need a specific type. So we create what we call abstract classes, right? And they're saying here that it's still meaningful or useful to have a pet class, and it captures all the things that pets have in common. We just don't want to make any specific objects that are just pets, right? So what we do is we add this keyword abstract to a class definition, and as it says, it exists now only to be a superclass. So by putting the word abstract in there, we're kind of saying my role is going to be a superclass. That's all I'm going to be. And it'll be a superclass for specific classes like dog, cat, bird, etc. And so therefore I can't do a phrase like this where I'm trying to make a new pet object. That won't work, right? Because this is abstract. It's just the superclass for other classes that'll be built from it or inherit from it, right? And notice that they raise this question here. It says that default speak method is a bit silly, right? Like, because no pets actually say hello, right? Like if they don't woof or meow or tweet or whatever, they don't really say hello. And so we don't really have a good default for it, is what they're saying. So, why is that really included? So we can also create, like we created an abstract class, we can also create an abstract method. And, you know, if we do that, and here's the interesting part of it, if we create a subclass of dog, cat, and bird, those must have a class within it that implement it. But pet doesn't have to, right? So pet doesn't have to include this, but we can define it as abstract, and therefore the other classes that inherit from it must include that as a method within them in order for it to be created, right? So in other words, if I do this, right, and notice what they're saying is abstract methods don't have a body, just a header. So you just say public abstract void speak, semicolon, you're done. You don't have to say anything else, right? And it says subclasses will override it automatically, basically, with their own implementation. All right. There's also this other concept that we throw around in object-oriented programming called polymorphism, and it's another one of those really fancy words. And if you look that word up, it literally means many forms, right? So we can take many forms for a certain thing. And it says a superclass variable can contain any of its subclasses, right? So for example, if I instantiate a pet and then I instantiate a pet called dog, a dog is a pet. And notice I'm using the new dog constructor, but ultimately it's a pet. Kind of weird, right? So it allows us to do that. That's kind of a weird aspect of this. And they say inheritance doesn't work in reverse though, right? So I can't take the dog class and instantiate a pet because dog is part of pet. So this won't work, but this would work, right? And I'll be real frank, this is not syntax I normally use, right? But it's conceivably possible. So we're just talking about that in terms of what these words mean, real frankly. Polymorphism really has a couple of other aspects to it as well, but that's kind of some of the key aspects of it here. Another really important construct in object-oriented programming is this concept of what we call an interface. And we kind of demonstrate this concept here by looking at sorting, right? So we'll start with this concept. Like if I create a list of instructors, for example, and then I add several instructors to the list of instructors, I can then run the sort method, which works on lists automatically. It's one of the methods of the list structure. It'll take the names that we put in and sort them alphabetically for us, right? So that's something we've sort of done already. And it is a built-in method that lists have, right? And it tells you something about lists, that lists are a type of object, right? And it says C# can sort simple types like strings and numbers automatically, right? So it's easy to put numbers in order and it's easy to put strings in order. But what if we wanted to sort customer objects? And notice the customer objects also have a customer number, but what is it going to sort on? Right? It's different when we have one string that's the whole name, because then we just sort alphabetically. But now I got three pieces of information, and if I try to sort this, what's going to happen? It's going to not run, right? You're going to get this error message during runtime because and I want you to read the error message and what it says. Invalid operation exception, failed to compare two elements in the array, system argument exception, at least one object must implement Icomparable, right? And so this won't run. So if we try to sort this information, it doesn't know what to sort. So in order for sort to work on this list now that has multiple data points for each thing inside of it, I have to declare what thing I'm sorting on. And the Icomparable thing comes into the mix, right? So Icomparable, right, is used when we build interfaces. So I want you to notice here the how we do this. We say public interface Icomparable, and what it basically is. So interfaces are basically a type of class, but they're an abstract class. So in other words, we're not going to build something directly from it. And notice what it says. They contain nothing except abstract methods, and you can't make an instance of it. But it features some things in there that allow us to compare one object to another object. So I can take the object that this sits within, and I can set up this interface called Icomparable, and then I can tell it what to compare to, or in other words, what to sort with. I can define it. And so this is pretty powerful. And okay, so they say interfaces are contracts, and I think that's kind of an interesting assertion. And it says we want C# to sort our list of customers, but we have to figure out what, once again, we're comparing it to. And so it says C# requires customer objects to have a compare to method, right, like this, in order for it to operate. So here's how we would implement that. So for whatever class we want to inherit from, and then we want to be able to sort it if it has multiple data points, we list the Icomparable. And I want you to notice the syntax here. It's very list-like, right, with the angle brackets, and what thing that we're sorting on. And what we're saying here is that we will declare what we're sorting on. And in this case, we would sort on the customer, or whatever that means, right? And the interesting fact is, right, that if we do that and we say sort, it won't compile until we add basically that compare to method and declare what is going to be sorting on. All right. So, all right, let's talk about the concept of sorting in the first place, right? Right. So they use this example. It says your friend wants help sorting his toy cars, and you pick up two cars, and okay, it's not like an alphabet and it's not like numbers. How do you decide how you're going to sort those? Do you go by the year, the model, the color? I don't know, whatever stampings are on the bottom, maybe the brand. I mean, you don't know, but your friend must have some idea, right? Like maybe it's like sports cars and trucks and whatever. But your friend has to tell you what the sort order is, and that's kind of a good way to explain what Icomparable does. So when we put in a compare to method and we add it to the customer object, that will feed in a different customer object as a parameter, and then we run the compare to method, and we declare we're going to take the last name compared to the other object's last name. And so now we're saying, well, what are we sorting on? We're sorting on the last name. Or maybe your friend wants to sort on color, but there's so many things you could sort on, so you have to specify. And this is kind of the method for doing it, right? So it says modify the dog class so you can sort a list of dog objects by age. And I've kind of expired all the slides here. So what I'm going to do is I'm going to look at my pet methods here. And I think maybe what I'm going to do as an example, I'm trying to find it in my code, so I apologize with the examples because I don't have them super ready. And I just want to show you, like, I got like 400 lines of code here. I'm trying to reason through. And there we have a pet and a cat, which is a pet, and a lizard, which is a pet, and a cow, which is a pet too. And that's where I did my comparable. So I guess I'm going to try to like reason through. All right. So here's my abstract class pet two. So follow along with me here. I'm going to share the code with you. I'm just trying to recall what I did last time. I just don't want to code this all from scratch, folks, is really kind of the real answer here. So I'm going to paste this in. Oops, sorry. Here it comes in the chat. All right. So I'm creating an abstract class called pet2, right? So we'll have a name and an age. And then we have a no arg constructor, and we have a to arg constructor. And then we have an abstract method for speak, and then an override for ToString. Right, that's the lay of the land on that one. Then I will create two additional classes. So here's, and Bob, did I send that last one directly to you? I did. Okay, so I apologize. I said I put it in the chat, but I sent it just to Bob, by the way. So Bob, you were special on that one. So here's the pet2 class. And now I'm going to throw in another class, right? And I'm going to just drop it right in here, which is a cow that inherits pet2, right? The unique feature of the cow is that it has spots, right? So it's a mammal, you know, I guess consider cows pets, some people do. And it has spots, it's a Boolean, so that'll be true or false. And then that has, notice, a one arg constructor, a two arg constructor. It has a speak method, which is required, and a ToString. Okay. Then one more, and this is where the Icomparable will come in. So here it is in the chat. And then I'm going to drop that one in here and just kind of break this one down. Now I have another class called cow2, which inherits from pet2. And I do an Icomparable. And notice I throw the cow2 designator in there. Once again, it has the same features as the other cow, has spots, has two constructors there, has a speak method, has a ToString method, and then it has a compare2 method that accepts a cow object. And then what are we comparing with the objects? We're comparing the age for the sorting. All right. Up to the top of the program now. And I'm going to comment out my company demo. And I'm going to call this, let's call this the interface demo. So now we're going to throw in that method here to run it. And yes, I will share the code. So bear with me here as I scroll through like 400 lines of code. And I have like a whole bunch of stuff. Okay, I'm gonna paste it back in, but I'm gonna give you the whole thing, and then I'm gonna explain what I did, because when I did this last time, I kind of did it incrementally, and what I'm trying to do here is kind of be time efficient with my coding, so we're not like watching me type for 45 minutes basically. So here's that code, and I'm going to drop it in the chat, and then I'm going to talk through what I did here, so you guys, and you know what, it's not going to fit, is it? Or no, I think it fit. Maybe it fit, maybe it didn't. No, it fit. Okay, I'm impressed that the chat can hold that much text, right? Usually you get like a couple hundred characters, and that's about it. All right, so let's take a look at this function here. So I start out by creating some cow2 objects, right? So I got cow1 and cow2. They're both new cows. And here I'm using the one arg constructor, basically saying it has spots, right? That cow's name is Sally. Its age is 5. And then I'm going to right line it. And then I create another cow. Her name is Betsy. She's 3 years old and she does not have spots. So she might be a brown cow, right? That kind of thing. And then we'll output that. We'll make that cow speak, right? And then we're going to run the compare to method, which is built into cow2. And we're going to compare cow2 to cow1. And then we're going to compare cow1 to cow2. Right. And I want you to notice here in the compare to methods what's happening. And I'm sorry for the fast scrolling. And I probably gave you a bunch of code you didn't even need here. But when we do the comparison here, what would be the result of this statement as really kind of what is this going to return actually? This is the question. All right. Let's run it and find out. And then we'll kind of break down. This is going to give us a lot more output than we're currently. Oh, okay. So it's giving me build errors. Why? Oh, I pasted it twice. Okay. All right. One more time. And what I'm going to try to do here is scroll the code so we can compare the output to the input. All right. So we created Sally, age 5. She says moo. It has spots, really that doesn't fit very well. And then we made it speak again and made it moo, right? Then there's Betsy, age 3, says moo. It does not have spots, and then moo. All right, so that takes us basically through this code right here, right? These first two sections. Then we do a compare, and I want you to notice the results of the Icomparable. In C#, I get a -1 for the first one when I compare cow2 to cow1. And then when I compare cow1 to cow2, I get a +1. So cow2 is 3 and cow1 is 5. So what does the -1 mean? Which one comes first?
Sally comes first.
Well, okay. Yeah, and okay, so there's actually 3 possible return values here. And what I did really quickly is, of course, I went to an AI engine and asked it really quick to explain. And I just put it in the chat. And I'm going to move that chat window over. I think this will show up in the video. But it says, if it's less than 0, in other words, -1, the current instance precedes the other object in the sort order. So cow2 precedes cow1. Okay, so look at the syntax here. Cow2 precedes cow1, so we get a -1. If it's greater than 1, the current instance follows the other in the sort order. So cow1 follows cow2. See that? If it's 0, they're in the same position, so they're in the same sort order. So if they were both the same age, and we could test that, of course, but that's the explanation of the output. Somebody was going to say something?
I was just say it wasn't showing up on my screen. It just is a gray box when you hovered over the.
Oh, okay. So maybe you guys can't see that particular window here. Did I
post
put
it
that
in
in
chat though?
Yeah, I put it in the chat so you can grab it from there if that's helpful. And really what I should do is I should augment that PowerPoint to include that information. as we kind of go down the list here, I did the example of the list of strings and sorting it. So that was just taken right from the slides. And then I went on. So I guess this part of it is pretty irrelevant for us. So I'm just going to delete that, folks. All right. Well, then we make a cow 4 and a cow 5, right? Give them different ages. We can add a bunch of different cows to a list, and then we can tell it to sort. And this is part of the power of this. We go through all the cows in the cow list, and then it'll output the cows with their ToString methods, right? And here's kind of an example of that, right? But the Icomparable piece is kind of useful because you can declare the sort order. You just have to understand what the return value is from Icomparable ultimately. All right. I think for now, let's take a moment and pause. All right, so now that we're done with all the lecture stuff, I'm going to go ahead and return back to our course shell here, and we are going to take a look at the assignment or the lab, excuse me, for module 7. So I'm going to pull that up on screen and we'll start talking about it a little bit. All right, so here's the preview on it. It says, congratulations, you've decided to start your own business. You've been working on your product for a long time and now you're ready to sell it. Write a program that displays your product and allows the user to view product descriptions about each product until they choose to exit. All right, so a lot of stuff is going to happen here. So let's kind of read through this list. All right, program requirements. An abstract class called product that contains the following: 4 properties, name, size, price, and description. It tells you the data types. 2 constructors, a no arg and a for arg constructor. So one that gives you defaults and one that would set all 4 values. And an override ToString method that prints all 4 properties. We also need a class for your specialized product. Can be any school appropriate product you want. I don't know, notebooks, sweatshirts, something like that. And that must inherit from the product class. It must contain at least 1 additional property. So whatever that happens to be. It depends on the kind of thing you're building, right? So what's your product, right? If you're doing a sweatshirt, it might have a property for size. If you're doing a notebook, it might have a number of pages, that kind of thing. 2 constructors, once again, a no arg and a 5 or more arg. Why would it be 5 or more? Well, because the abstract class product has 4 to begin with, right? So if we're going to build that, we're going to have at least 4. So it's got to be 5 or more, depending on how many properties you have. And then once again, an override ToString that includes the base data plus the new data for the class. Then we'll have a driver class with a main, right? And if you choose, you can write the classes inside the same file like we were just doing, or you can make them separate files. That's all on you, right? How you choose to do it. In that main method, you'll populate a list with some specialized products. And it says this could be hard-coded, so you might want to do that. And then print a menu and allow the user to view the product data and then exit when the user chooses to. So we'll put a menu on the screen with like a few options and then an exit option to go with it, right? That sounds like a loop. We've done that before. It says extra credit, 2 points for input validation. So in other words, whenever we're asking a person for information and they type in what we don't want, we will find a way to let them know and let them correct it. Right. So a lot of stuff to do there. So they have a sample program run. So let's take a look at that. And notice this has input validation. So, all right. So they have a salsa menu. That sounds pretty tasty. Right. I haven't had dinner yet. So right now the mention of food makes me hungry. All right. So option 0 is to exit. And then we have Scorpion Sting, Mom Salsa, She Ghosted Me, and Mean Green. So you choose a product, and then it'll put it up on screen. Looks like it indicates a heat level and a price, right? Um, and a description, right? Any key to continue. So then you press your key and it takes you back to the menu. You choose a product that's not on the list and it gives you some feedback. It says invalid entry. Back to the menu. Excuse me. Um, Once again, type in a letter, invalid entry. So we're gonna have to figure out how to deal with letters and numbers here, right? Um, Once again, we'll give them the option to exit and then they'll get out. But notice we'll have a list of products, an exit option, a menu, handle invalid input, and then when you choose to exit, have a little message that says you're closing the application. So a bunch of different things to build here, but what I'm seeing is we're going to build an abstract class. We're going to build a specialized product class, which of course has to inherit from the abstract. A driver class with main, and then this input validation thing, which is extra credit. All right, so here's what I suggest that we do. Let's at least get started on this. And we don't have to build all of it right now, but I think that what would be wise to do is at least build the skeletal structure of it. And then when we come back next time, we can start populating it, right? So that's kind of my goal here for the evening. And then with any luck, we'll end a few minutes early, and I think everybody would appreciate that too. So back here in Visual Studio, I'm going to close my existing solution, and I am going to create a new project. And let's call it module 7. I don't know, do we want to do salsa? It sounds good to me. I'll call it the salsa, module 7. How about this? Module 7 lab. And I'm going to call it product. How about that? And then you can, if you know what kind of product you want to build, kind of products you want to offer, type that into the name, I guess. All right. We are going to leave the top level statements in at this point. And then what I'm going to do here on my other screen is I'm going to find my previous solution here. I'm just curious as to what I created last time. Did I really do salsa is kind of the question. And it looks like I did. All right, I did do salsa. Okay, I did salsa, so I followed pretty much the example that sits there. Now, inside the main method, I'm just going to put a comment for now, and I'm going to say this is the program driver method. And so this is where we're going to run everything from. Right. So right now I don't have any code to put in here. I'm more worried about creating the class structures than anything else. All right. Now the question becomes, if I'm going to build some classes, do I do that in a separate file or do I do that right here? And I'm going to leave that up to you. What I think I'm going to do is I'm actually going to build a separate file. It's what I did last time. And in that separate file, I included the abstract class and the inherited class both. So I'm going to come over to Solution Explorer. I don't want to right click on top of one of the files. I want to right click on top of the module, and then I can go ahead and add a class file. We're just going to make that a class. And last time I called that product. And notice that's the name of the abstract class, by the way. So there it is. Now, the first thing I'm going to do is I'm going to change this keyword in front of it from internal to abstract. Right, so that allows us to abstract it. And then we're going to have a bunch of data fields. So I'm going to say data fields. I'm not worried about building those yet. I'm just placeholders. Data fields. We need a no arg constructor. We need a for arg constructor. We need a override ToString. Oops. And I think that's all of what we needed. But you notice how I'm doing this? I'm creating kind of like a to-do list for myself. And I'm not worried about coding it right now, but I'm making a list. I'm kind of like taking the instructions and sort of pseudocoding it. I'm creating a script basically for what I'm going to do. And that way I don't have to bounce around. And when I get to building the constructors, of course, I'm going to want more detail, and I'll go back to the instructions and pull it in. But here's kind of like the rough approximation of basically my skeleton for the abstract class. Then I'm going to create another class here. And if you want, you can make this a public class, but I'm just going to say class. And I will call it salsa, and that's going to inherit from product. And then we'll put in our curly brackets, and I'm going to follow the same approach. Okay, how about a minimum of one additional data field, right? And then it said, once again, a no arg constructor, a 5 or more arg constructor, and I think the only other thing we have to do is an override ToString method. And these would be the class structures that we have. Right. And notice how I'm kind of like, all right, got the grand, broad sweeping strokes of what I'm going to do here listed already. I'm going to go ahead and save this file. We won't code this until Thursday, though. But I have a script I can follow. Now, back in the main program, that had kind of a set of instructions, and I'm trying to find those instructions here. Let me pull them up on the screen. Must inherit, additional property. Okay, so we did all that stuff. We're good. Okay, a driver class with a main, populate a list with specialized product. Okay, so let me just, okay, here's kind of an easy way to do it, I suppose. I could just grab this and drop these in. And of course, then I can do my CSS style commenting. Populate a list with some specialized products. Print a menu and allow the user to view the product data. Exit when the user chooses to. And then the other piece was extra credit, add input validation. Okay, so that gives me my roadmap for where I'm going with this. And I think I'm ready to call it a night. I think this is enough work for one night, but notice what I did for myself. When I come back to this, I'm ready to roll, right? Might have to pull a few details, but I got the general concept. And I think this is a good place to end tonight, folks. A lot of material to absorb. And I think what I'll do here is I'll stop the video here. So this will end here. So we'll complete this lab on Thursday. And the video is